When you look out at the vast expanse of ocean that covers most of our planet, it might be easy to think that all ocean water is the same. After all, it mixes together, usually looks the same, and animals swim throughout it seamlessly. But the oceans are made up of many different water types, moving past each other and across each other, and up and down and every which way. Surface currents occur when water moves laterally at the surface. These currents are driven primarily by wind, and sailors depend on them in order to reach their destinations. But there are also upwellings and downwellings, in which water moves vertically, transporting dissolved nutrients and moving heat. So what makes water move up and down? Vertical water movement, like upwelling, is driven by density. Ocean water density is determined by its salinity, or how many dissolved particles are in it, and the temperature. The coldest, saltiest water on Earth is the most dense, and thus sinks down in the water column when surrounded by warmer or fresher water. For example, warm surface currents near the equator move towards the poles where the cooler air causes them to lose heat. This makes them more dense, and they eventually sink in a downwelling. The constant movement of surface and vertical currents across the globe, driven by temperature and salinity, is called thermohaline circulation. And if you could see the currents, would look like a series of constant conveyor belts. Upwellings usually occur when deep, salty, cold currents that move along the bottom of the oceans run into a continent and have nowhere to go but up. They rise to the surface, bringing cold, nutrient-rich waters from the deep, which has big effects on the local ecosystem and the climate. Upwellings are very important zones for living things. But why? Funny enough, the same reason why an open can of soda holds its fizziness longer when stored in your fridge than if you left it out at room temperature. Gases, like the carbon dioxide that makes your soda fizzy, stay dissolved better in colder liquids than in warmer liquids. So, a warm soda will go flat much more quickly than a cold one. Likewise, oxygen is a dissolved gas, and a very important nutrient for living things. Cold seawater holds more oxygen than warmer seawater. So, that cold, salty, upwelling water brings with it lots of dissolved oxygen and other compounds that provide a smorgasbord of nutrients for plankton, plants, and algae that are the base of the food chain. For this reason, areas of upwelling across the globe tend to have the richest ecosystems with the highest abundance of organisms. The strongest upwellings in the world tend to be on the western boundaries of continents. This is mainly because Earth is rotating towards the east, pulling surface water with it, leaving space for deep water to rise up along the western coastlines. In North America, the strongest upwelling regions occur along the California coast, all the way up to the Aleutian Trench of Alaska. The western side of South America, from Colombia all the way down to Chile, also has a strong upwelling. Both regions boast a huge abundance of marine life. Fish, invertebrates, and kelp forests make it some of the most beautiful, though cold waters to explore. Because the water is so cold, it tends to have a big impact on the climate of the surface area, including the surrounding land. These regions tend to have cooler climates than areas with warmer waters, though at the same latitudes. Ocean currents involve the lateral movement of water, with both surface currents and the vertical movement of water, with upwelling and downwelling, together driving the global conveyor belt known as thermohaline circulation. Upwellings occur when cold, salty, dense water rises to the surface, bringing with it an abundance of dissolved nutrients, and a cold climate for any surrounding land. Earth's rotation and the presence of continents drive upwellings, which tend to occur along the western coastlines of major continents. Because of the high amount of dissolved oxygen and nutrients, upwelling areas are associated with a very high abundance of marine life. These are some of the richest ecosystems on Earth.